So here you have Paul borrows rupees 20,000 on condition to repay it with compound interest at 5% per annum in annual installment of rupees 2,000 each. Find the number of years in which the debt would be paid off. So you need to find out n. So we have a case of P is equal to R upon I into 1 plus I raised to n minus 1 upon 1 plus I raised to n. So we need to find n here. So P is going to be 20,000 is equal to 20,000 2,000 upon I, which is 0.05 into 1.05 raised to n minus 1 divided by 1.05 raised to n. So we will have 20,000 into 0.05 into 1.05 raised to n upon 2,000 is equal to 1.05 raised to n minus 1. Let's see what we have here. This turns out to be 10 into 0.05 is going to be 0.5 into 1.05 raised to n is equal to 1.05 raised to n minus 1. You can take out common factor and you end up getting 1 is equal to 1.05 raised to n. You take it to this side and you get 1 minus 0.5, which means that 1.05 raised to n is 1 upon 0.5. 1 upon 0.5, which will be 2. So ultimately 1.05 raised to n is 2. Now you need to find n. So it has to be 1.05 into how many times by itself will give closest to 2. So into 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 1.05 into 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and yes, so 1.05 raised to 15 turns out to be around 2.07, so roughly around 2. So n turns out to be 15 years. So n is 15 years. You're just making the calculations in rough. You can just simplify this and you get it. So you get 15 years. Okay, so we have 15 years. Okay, further. Okay. All right. A person invests rupees 500 at the end of each year with a bank which pays interest at 10% per annum compound interest. The amount standing to his credit 1 year after he has made his yearly investment for the 12th term. So basically, he is making some deposits like this for 12 years and then he gets something. At the end of 12 years, it has amounted to something, but he is not further depositing. He is withdrawing the amount after another 1 year. So he is not depositing anything. It is just that whatever is the amount that has accrued till now, to that you are going to add 0.1% of it. So ultimately, you need to calculate the future value for 12 years. You need to calculate the future value for 12 years with R upon I into 1 plus I raised to n minus 1, and that into 1.1 will give you the total amount that he is going to get. That is a question, because he is depositing for 12 years at the end of 1 year for 12 years, and after that he neither withdraws. He doesn't withdraw, let the amount accumulate. So 1 more year the accumulated amount will gain 0.1. It is not told that he is further paying another 500 at the end of 13th year too. So hence you have R, which is going to be 500 upon 0.1 into 1.1 raised to 12 minus 1. Let's calculate this. So it's going to be 1.1 into 12. Right. Minus 1 into 500 divided by 0.1. So this alone turns out to be around 10,692.14. And then for one more year it accrues an interest of 0.1%. 0.1. So that means the amount will turn out to be into 1 plus 0.1, that is 1.1. So let's see what is 1.1. It turns out to be around 11,761.35. 11,761.35 is the value of it. So the concept is you calculate for 12 years and then into 1.1 and you get 11,761.35. So we get 11,761.35. It's closest to this, but there is a difference of more than 3 rupees. So we'll go in for none of these. Let's see what we have. Oh yes, right, it turns out to be that. So you have a company borrows rupees 10,000 on condition to repay it with compound interest at 5% per annum by annual installment of rupees 1,000 each, the number of years by which the debt will be paid clear. So it's borrowing 10,000 currently, which it's going to pay as 1,000 rupees at the end. So what formula do we use? Definitely not future value, it's going to be the present value formula. So we need to find out this. So we have P is equal to R upon I into 1 plus I raised to n minus 1 upon 1 plus I raised to n. So this turns out to be 10,000 and you're going to cross it into 0.1, 0.05, I'm sorry, upon R upon 1,000 is equal to 1.05 raised to n minus 1 upon 1.05 raised to n. So let's calculate this. This turns out to be 10 into 0. It's going to be 0.5. Cross multiply this turns out to be 1.05 raised to n is equal to 1.05 raised to n minus 1. You can take 1 this side and this side and you get 1 is equal to 1.05 raised to n minus 0.5 into 1.05 raised to n, and here you can take 1.05 raised to n common. You get 1 minus 0.5. So ultimately 1 upon 0.5 is 1.05 raised to n. In other words, 1.05 raised to n is 2. So 1.05 into 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if n is 1.9799, then you get, when n is 14, you get 1.05 raised to n is this. So among these 14.2. So that means 2 could be somewhere close to this. So roughly around 14.2 years would be closest to this, because there is an option over here which is very close to 2 and it is a little more than this. Hence n can be roughly taken to be 14.2 years. So we have 14.2 years as the answer. Okay, so we have 14.2 years. Now we have a person bought a house paying 20,000 cash down and rupees 4,000 at the end of each year for 25 years at 5%. The cash down price is what? So, he is paying 4,000 at the end of each year, and the cash down price is what? So, he is obviously taking some loan to pay the balance beyond 20,000. So, 20,000 rupees has been paid, and the balance amount, whatever it be, say X, is being paid in terms of 4,000 rupees at the end of 25 years, which means that that balance amount is actually the present value. So we need to find the present value of installments of annuities of 4,000 for 25 years at 5%. Hence, we use the formula P is equal to R by I into 1 plus I raised to n minus 1 upon 1 plus I raised to n. So R turns out to be, of course, 4,000 upon 0.05 into 1.05 raised to 25 minus 1 upon 1.05 raised to 25. So 0.05 into 2, 3, 4, 5, 6, 7. And you get around 1.05 raised to 25 is around 3.3863549407. Divided by 3.28625. This turns out to be around 56,375 rupees, 70 paise odd. Now this is the amount that is the present value of all these installments that he has paid. Plus he has paid 20,000 also. So the cash value, cash down price is actually plus 20,000 because it's 7573. So it's 76,375 rupees 70 paise. Now this is quite close to this, so we can take this. So the concept is you don't have to worry about the 20,000 in the initially. So the question is cash down price means how much amount of what would be the cost of this whole transaction. So you need to first find how much is being, what is the present value of all the installments he has made. That is going to be the present value of the house minus from the present value of the house minus 20,000. So hence to find the current cash down value, which is going to be whatever you found out, the present value plus 20,000 will give you the cash down price. So it's 76,375. Yes, turns out to be the same. Okay. A man purchased a house valued at rupees 3 lakh. He paid rupees 2 lakh at the time of purchase and agreed to pay the balance with interest at 12% per annum, compounded half yearly in 20 equal half yearly installments. So how does this affect it? It's going to be half yearly installments. So n in any case is going to be 20, but it's 12% per annum. So I will turn out to be 0.06. So 20 half yearly installments, you need to have to change the 20, would remain 20 itself. And he's taking a loan for 100,000. So the current value of the loan is 100,000. Because he has paid 200,000, and you need to find R. So it's going to be P, which is 100,000, is equal to R upon 0.06 into 1.06 raised to n, that is 20 minus 1 upon 1.06 raised to 20. So let's see what we have here. 1.06 raised to 20. So it turns out to be 3.20713547209. That is 1.06 raised to 20. It will help us to do this calculation. Then we have minus 1, which we store it in memory. Okay. Next we take 1, 2, 0, 0, 0, into 0.06 into 3.20713547209 divided by, it turns out to be, R turns out to be roughly around 8,718 rupees 45 paise, roughly around this much. So that means he has to pay 8,780 at the end of every half year for 20 such half years, so that it realizes its present value will turn out to be 100,000. So among these, this is the right answer. Okay. Similar to this is what we have over here. We have Vipul purchases a car for rupees 5,50,000. He gets a loan of rupees 500,000 at 15% per annum from a bank, and balance rupees 50,000 is paid at the time of purchase. He has to pay the whole amount of loan in 12 equal monthly installments, so EMIs, with interest starting from the end of first month. So you have here at the end 12. So there are 12 equal monthly installments, so n is equal to 12 and I would be 0.15, it is 50% per annum, divided by 12, which turns out to be 0.0125, which means that he has to pay the money he has to pay at the end of every month. So that means we need to find R. Again, it's a case of loan. So he takes a loan of 500,000. So P, which is 500,000, is equal to R upon I, which is 0.0125. 1 plus I, 1.0125 raised to n, that is 12 minus 1, divided by 1.0125 raised to 12. Now this here, since the value has been given, R will turn out to be 500,000 into 0.0125 into this has been given as 1.160754517767 divided by 1.1607 turns out to be 0.160754517767. Let's see what we get here. You have which turns out to be roughly around 45,129 rupees. 15 paise. 45,129.15 paise, which is almost close to this. The difference is a little more than 1. We can take this as the right answer. 45,129.15 you get, which is roughly around this. So the correct answer among these is 45,130.43. Let's see what we have. Yes. Okay. What do we have here? Johnson left rupees 1 lakh with the direction that it should be divided in such a way that his minor sons Tom, Dick and Harry, aged 9, 12 and 15 years, should each receive equally after attaining the age of 25 years. He is not depositing any amount, so it's not actually an annuity, but still it is an interesting, so maybe you could see how it works. The rate of interest being 3.5%. So you have I as I is 0.035. Now, what does it mean? The 1 lakh is distributed into 3 amounts, A, B and C. A is given to deposit for Harry maybe. B is deposited for, A is deposited for Tom, B is deposited for Dick and C is deposited for this one, the last person, that is Harry. The amount deposited is not the same, but finally when each one turns out to be 25 years, the amount that each one of them gets is going to be the same. In other words, suppose A is the amount that is deposited out of 100,000 is the amount deposited for Tom. So it's going to accrue interest for 25 minus 9. 16 years. So it's going to be 1.035 raised to 16. He's going to get this much amount. Then Dick is going to get for 25 minus 12, 13 years. So the same rate, 1.035, he will get it for 13 years. Then the last one, C, that is Harry, is going to get for 25 minus 5, 10 years. Minus 15, I'm sorry, 10 years. So he is going to get interest. So the amount that he is going to get is the amount that was deposited for him into 1 plus the rate raised to n, that is going to be 10. Now all these amounts are equal. Let them be equal to, say, K. That means, which means that A is going to be K upon 1.035 raised to 16. B would be K upon 1.035 raised to 13. And C would be K upon 1.035 raised to 10. But we also know A plus B plus C is 1 lakh. This is also known to us. So we'll substitute these values and find the value of K, which is what we need to find, which means that 100,000 is going to be A, which is K upon 1.035 raised to 16 plus K into 1.035 raised to 13 plus K upon 1.035 raised to 10. Now among these, the biggest value, either you take LCM or multiply both sides by 1.035 raised to 16. If you do that, you get 100,000 into 1.035 raised to 16 is equal to, you can take out K common and you get 1 multiplied by this gives 1.035 raised to 3 plus 1.035 raised to 6. So we need to calculate these values. Let's see what we get. 0.035 into 16 into we get 17338.60 3977. Maybe you could put this in memory, store this in memory. Oh no, that's not. So, and we need to do also 1.035 into 3. plus 1. So this turns out to be K into 3.33797,320,133. So let's see what we get. 7, 3, 3, 9, 8, 6, 0, 3, 9, 7, 7 divided by 3.33797,320,133. It roughly, K turns out to be roughly 51,947 rupees 27 paise, which means he deposits 51,000. That means each one would be getting 51,947.27. Remember, please do not mix this up with annuity because there is no regular amount that is being deposited. Obviously, the amount deposited for Tom would be much less because he is going to get interest for a long time. Dick would be a little more, and the last one, Harry, would be given the maximum amount of deposit, but ultimately all of them will earn the same amount of 51,947.27. Hence, this is how we get it. So the correct answer among these is none among these. Okay. Furthermore, Alibaba borrows rupees 6 lakhs housing loan at 6% repayable in 20 annual installments commencing at the end of the first year. How much annual payment is necessary? So obviously again present lakhs, so present value, so it's going to be 600,000 present value, and N is 20, I is 0.06, and you need to find R. So it's going to be P, that is 600,000 is equal to R upon 0.06, 1.06 raised to 20 minus 1 upon 1.06 raised to 20. So let's see what we get that. 1.06 into 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. So it turns out to be 1.06 raised to 20 is 3.207,135,47209 minus 1, and store it in memory, and you have 600 into 0.06 into 3.207,135,47209 divided by, it turns out to be roughly around, R turns out to be 52,310 rupees 70 paise or something. So among these, this is the correct answer. R turns out to be 52,310. Okay. So we have, these are the various types of common examples that we are doing in annuity. Okay. Now see here what we have. Raja, aged 40, wished his wife Rani to have rupees 40 lakhs at his death. If his expectation of life is another 30 years, and he starts making equal annual investments commencing now at 3% compound interest, how much should he invest annually? So again, it's a case of future value. So future value has A, that is A for 30 years. A for 30 years turns out to be 40 lakhs. And I turns out to be 0.03, and you need to find out R. So and N of course is 30. So we have A, that is 40 lakhs, is equal to R, which we don't know, upon I, which is 0.03, into 1 plus I, that is 1.03 raised to 30 minus 1. Right. So we do 1.03 into okay, minus 1. Okay, then you have 40 lakhs into 0.03. So roughly R turns out to be roughly around 84,077 rupees and 3 paise. That means annually he deposits this much amount, because R will turn out to be 40 lakhs into 0.03 upon 1.03 raised to 30 minus 1, which will be 84,077. Do we have it? Yes, we do have it, right? 84,077. Okay, so what do we have here? Apu retires at 60 years, receiving a pension of 14,400 a year, paid in half-yearly installments for rest of his life. After assuming his life expectation to be 13 years, or calculating, that interest at 4% per annum is payable half-yearly. So here, modifications have to be done in terms of half a year. Everything has to be done because he's making to be 13 years. So accordingly, hence in 13 years, there are 26 half years, because it is being calculated once in 6 months or in half year. The rate also becomes, since this is per annum, per half year, I turns out to be 0.02, and this is the pension, annual pension. So that means R is going to be half of 14,400, that is 7,000. The 6 monthly pension is 7,200. Hence, we need to find out what single sum is equivalent to his pension. That means his entire pension that he gets whatever he gets over a period of 13 years, what is that single sum currently which is equivalent of this? So we need to find out present value, which is R upon I into 1 plus I raised to n minus 1 upon 1 plus I raised to n, which in turn turns out to be R is 7,200 upon I, which is 0.02 into 1.02 raised to 26 minus 1 upon 1.02 raised to 26. So let's see what we have here. We need to calculate 1.02 into 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it turns out to be 1.67341811,423. That is 1.02 raised to 26. So minus 1 into 7,200 divided by 0.02 divided by 1.673411,811,423, which turns out to be 1,44,872. One second. Let's check this. That's 1.02 into, it turns out to be that. minus 1, okay, into 7200 divided by 0.02 divided by 1.673418143. You get 1,44,872 rupees, 1 rupee 45 paise, which is roughly around 871. 1,44,871 could be the present value of all the amounts that is deposited. So among these, the closest to this is 871. You have this and this. Obviously 871 is closer to this, so it's option number B, 1,44,900 would be the answer for this. Okay, so we have 1,44,900 would be the right answer.